Hi, welcome back to LeetCode. So in this video, I am going to discuss LeetCode problem 3552, grid teleportation traversal. So you are given a 2D character grid matrix of size m cross n. So this is rectangular ultimately. Not it may be a square, may not be, because m and cross both are actually different. So represented it as an array of strings. Okay, her matrix I comma j represent the cell at the intersection of the ith row and jth column. Okay, each cell is one of the following: dot representing an empty cell. Okay, if it is has representing an obstacle, and an uppercase letter A to Z represent a teleportation portal. So you start at the top left cell at 0 comma 0, and your goal is to reach bottom right cell. So that means m minus 1 comma n minus 1. You can move from the current cell to any adjacent cell, up, down, left, right. So I mean, this is ultimately 4 direction you can actually move, correct, as long as the destination cell is within the grid bounds and is not an obstacle. So you can only move the next cell if it is in the actually valid, means this is actually valid present within this range, and also that cell actually no obstacle is present on that cell, then actually you can only move that cell. So if you step on a cell containing a portal letter and you have not used that portal letter before, you may instantly teleport to any other cell in the grid with the same letter. So this teleportation does not count as a move, but each portal letter can be used at most once during your journey. Okay, so return the minimum number of moves required to reach the bottom right cell. So if it is not possible to reach the destination, we have to return -1. Got it? Now, what they are trying to say? So we know that our starting or source position is 0 comma 0, and we have to reach destination row -1 comma column -1, correct. This is clear. Another, actually they mentioned that how actually we can move. First of all, we can move only 4 direction: left, right, up, down, correct. But how actually we can move if it the next cell is valid, means if I try to move on the upward side, then we should have that we should actually have some cell in that upward side, correct. And also there should not be any obstacle on that cell, means obstacle means has, correct. Empty cell we can move. If there is any correct letter, then actually we can also move, but if there is an obstacle, we can't move to that cell, correct. Now um, now another, actually what actually we can do, suppose we actually have some cell in this matrix. Suppose here it is A, here also it is A. Suppose here actually somehow we actually reached in this cell by steps, x number of steps moves I have reached in this cell. So they're actually trying to say here that we can also move to this cell also, or actually the cell actually present A also, character A. We can directly move to this cell without any moves. Means we can actually by using X moves, I can reach to this cell also. They are trying to this. Actually, you can see that before you may instantly teleport to any other cell in the grid with the same letter. That means in this grid, whatever the other character same character is present, however the in the cell the same character is present, we can actually move without any move, extra move. This teleportation does not count as a move, so this move will not be counted as a move. Okay, so this is clear. And we can use only, suppose we have reached here also in this cell by using from this cell, okay, because by using teleportation. But again we can't use A here, because they mentioned that only we can use A at most once in the uh, entire visitation. So how can you do that? So suppose I will add this condition letter, the teleportation move. Okay, first of all, if there is no teleportation, then what actually we should do? We know that by brute force approach that we will start from we know that our source and I know our destination. So I will start with the DFS. What will do? I'll start from this cell and I will explore all the neighbors. Mean here actually there are 4 neighbors possible. Suppose here actually currently I'm here, so I can move to this cell, this cell, this cell, this cell, correct? And when actually I can move if there is no obstacle, correct? So I'll check that if the next cell is not a obstacle, or that means has, then actually I can only move. Then what actually the moves number of steps. So I am starting from initial number of steps will be 0 because I have not any used any steps here. So whenever I go to the next any neighbors next cell, then what will be the number of steps? Whatever the steps actually currently I have, and plus 1, because this is one more steps I am going to use. So when actually I can find out what we have to do, we have to find the minimum number of steps we need. So that means suppose in this matrix if there is no teleportation, what I'll do, I know that this is our starting cell and this is our destination. So what I'll do, first of all I'll go to this cell. So number of steps here actually 1, then this is actually 2, then again here it is number of steps I have used 3, here actually I have reached 4. So in this path I have used 4 moves. Okay, so I in answer variable I will store 4. Next what I'll do, so by if I don't go to the want to go to the right, then actually I can go to the downside also, correct, in this path. So suppose here actually I am instead of the right side I have actually exploring the downside. So this is again step number will be 2, here it will be actually 3, again it is 4. So in this path also we are using 4 steps. Okay, so if I instead of go to the downside I can go to the right, so this will be the number of steps will be 3, and again this is 4. Clear? In this actually I will explore all the paths, possible paths. Then ultimately whenever I reach the destination, I know that destination will be row minus 1 comma column minus 1. Then I'll check that how many steps I am using, by how many steps I have reached here in this position, so that I will compare with the answer variable. If there is no if answer is still, it will be minimized, so I have to initialize with int max or infinity plus infinity. So after explaining all the path, if there is still the destination is the distance is number of moves is still infinity plus infinity, positive infinity, that means there is no possible path I am able to reach the destination. So that time I have to return -1. This is clear. The brute force approach when there is no teleportation. Now what is I can do? So for teleportation, 1 minute. So I know that this is our starting cell. Okay, so here extra condition what they have added. So in teleportation I will say okay, this is a letter, uppercase letter between A to Z. That means I can use that this teleportation moves here, but using that moves, because before we have to check that, first we have to check that I have used this A like teleportation on A previously or not. If it is we have used previously, then we can't use here. So that's why I need actually one used or not something for A to Z. So initially all will be false, correct? Now I will say that okay, this A is the first time I am seeing A, so I can use the teleportation here. Okay, so how many steps I have reached here? 0. Okay, and I will mark this as true because I have used teleportation on A. Next, horizontal I can reach, if I use the teleportation, I can reach this same character present in this cell also. So by how many moves? 0, correct? 0 moves. Now what actually I can do? Again actually here actually I can actually use this teleportation. No, because I have already used the teleportation on character A. Now what actually I can do? I can actually move that neighbors formula, means the 4 direction, up, down, left, right. So I will explore this. So this is by how many steps I can reach here? 1. So because this actually I've reached 0, this A, and I'm using 1 moves, so this is actually 1. Then actually I can go to this cell by using 1 more move, so this will be 2. Ultimately we are using 2 moves. Okay, so if I use this like normal moves here, so this will be take 1 moves. So again actually I can do 1 move, so ultimately this so ultimately this is second move, third move, fourth move. So still our minimum moves is 2. So ultimately you will see that after explaining all the possibilities path, I got actually minimum number of moves is 2. Got it? Extra condition you understood. So what actually I need here? So first of all we need like one map that what is the position for A in the grid, input grid. So suppose this will be I1 comma J1, then I2 comma J2, in this way I3 comma J3, because here will be row comma column. So that's why I need actually this. In this actually I can actually map that or actually I have seen A. Okay, similarly for B also, similarly for C. In this way for Z I will actually store all the position I have seen this character. Okay, now what I'll do for DFS, I'll start from source 0 comma 0, and I know that my number of moves I have used here is 0. Then I will check that in the current cell like I comma j, currently I am in j, I comma j, if it is a letter means between A to Z, that means I can use a teleportation here. So what will do, I'll first of all I'll check that have I used this teleportation on this character before or not. If it is I have already used, then I can't use. Okay, so I go to the directly I explore the all the neighbors here. Suppose currently I am here I comma j. So what is the neighbors are possible? This will be I minus 1 comma j, this will be I plus 1 comma j, and this will be I comma j minus 1, and this will be I comma j plus 1. Clear? So I'll go to the next by using plus 1 move. So in this actually when I reached that because I know that how many by using how many steps I have reached in this I comma j, then I will add the plus 1 and I will go to the next cell. Similarly on that cell also I will check that is there any teleportation moves possible or not. If it is possible, then I will go to the that other cell that letter is present by using the same steps. Correct? So this is clear, DFS is clear. So this will take the more time. Why? Because I am exploring all the possibilities. Suppose I am exploring this path, suppose this path, and again I am exploring this path, and similarly for this path also in this way. So what will be possible that I am exploring the first, it may possible that this is the longest path first I have explored, then I the in between length actually I got, then actually I got the minimum length. But if I use the BFS here, then actually what actually I can optimize, I know that in BFS first I will always get the minimum steps, or actually I have used minimum steps I have used to reach some cell I comma j, some assuming some cell I comma j I have reached some number of steps. So what I'll do, I'll use that first, explore that minimum first. So I know that whenever actually reach the first, like in BFS I'm exploring the minimum steps first. So what will happen that I know that it's guaranteed that I will reach the destination row minus 1 comma column minus 1 first time by using the minimum steps. I know that whenever I go to the next whenever I reach the same destination, but it will take at least the same distance or more than that, not possible to minimum. So in this way I can actually ensure that this will take minimum time. Got it? So in DFS, but we can't actually ensure that in this particular hierarchy I will get the minimum distance. So again we have to export this hierarchy also. Correct? So that's why I can't ensure that. So that's why I can use the BFS here to optimize that. Got it? So how can I actually use the BFS here? So we all know that shortest distance from source to destination in graph. So similar way actually I will explore here, but extra condition here it is that the teleportation moves. Correct? So in shortest distance in source to destination by using BFS, what actually I need actually one distance vector. It contains that from source to this particular node 0, node 1, node 2, node 3, what is the distance? So what is the minimum distance? So initially all are empty. So I know that this starting source, the distance will be 0 because this is the starting node. So that's why I'll mark this as a 0. So now what I'll do? So what I have to know, I have to know the steps and the position, node number. So what I'll do, first of all, so I will pop this because this is the first node. I will get the BFS, so I'll get the node. So what will do, I can actually check that this actually teleportation move is possible or not, similar way. So if it is possible, then what I have to do, I know that first of all I have to traverse the entire grid, the matrix, input matrix, to know that where the character A is present, where the character B is present, similarly for C, in is for Z. So ultimately I actually have this in a map. So suppose this is our character A in this current node, suppose. So what actually I can do by using teleportation. So I know that by using steps and by using this number of steps, I have reached this node, and this node is a character A. So I suppose I have not used this teleportation on character A, so I can use this. Okay. So first of all, I have to know that the position 1, position 2, and position 3. So what will be the steps to reach position 1? It will be the same number of steps. I have ensured that this is the minimum number of steps to reach this character A. So this will be the same for reach to P2, position 3, position 2, position 1. So what is I can do? I will store that to reach the destination P2. Suppose this is P2 and this is P3, suppose. So in P2 I can ensure that it will take the same distance, means here the steps. Here actually the weight is same. Got it? So I will export this and I will store this into the queue again. The number of steps will be same, and P2 similarly for steps of P3 and steps of P1. Got it? This will be the same distance. By using the same number of steps, I can reach this position also by using teleportation, and I will mark this teleportation as true. Teleportation used or not. So I'll mark for A as true. Got it? Next, for this also, what actually I can do, I can actually go to the neighbor also. So currently I am in node, correct, in node. So I can explore the 4 neighbors are possible. So this will be the node minus suppose x minus 1 comma j. I've already explained these 4 possible neighbors are possible. So again I have to check that if this cell actually is or not an obstacle is present in this cell, so I can actually go to this cell by using the same number of steps plus 1, because 1 move I need. Correct? Got it? In this actually, whenever I reach the destination, the row minus 1 comma column minus 1, I can actually return the number of steps I have used here. Got it? So if any doubt, any suggestion, you will comment on that. Now go to the code. That will be more easy to understand this logic here. So first of all, find out the number of rows in the matrix and number of columns. Okay. So initially I need actually the distance matrix. That will actually give us the what is the distance to reach from the source to this particular I comma j particular cell. What is the minimum distance I can reach? So initially it will be in max, means this is not possible to reach because I have not seen any path to reach. So that's why initially it is in max. And map for this what? Map is for that particular character A, or actually this position of what the position of the cells this contains A. Got it? So that's why the here key will be the character like for A, and then there are multiple position possible. So that's a vector of positions, means pair, means row comma column. So that's why I've taken a pair. So and also used here what actually it is significant. It signifies that this teleportation, this character, there is 26 character possible for A to Z. So first of all we need to then know that this teleportation, in teleportation I have used this character or not. So that's initially false, and true means if it is true, that means I have already used this character in the teleportation. So first of all I am traversing the whole matrix, and if it is a character, means A to Z, between A to Z, so this is a letter. So what I can do, I will store the position for particular this character. I am storing this I comma j. Got it? In this I actually have the entire position of the character. Now what I have to store? I have to store the priority queue. Priority queue will be what? It will store that distance by using how many steps I have used I comma j. So I need three things. One is the first will be the key will be the minimum steps. I have to first explore the minimum steps. So that's why the first key will be the steps. Next will be the I comma j, because here are the two things I need to know the ultimate node position. Got it? And I have used this priority queue, and this is minimum mean heap. So that's why it will always give us the minimum steps I have used to reach this particular cell. And I know there are four neighbors are possible. You can see that 0, 1, 1, 0, 0, -1, -1, 0. Right? And initially, what actually starting cell will be the 0, 0, and how many steps I have used here? 0. So that's why first 0 is the distance, the number of steps, and this second and third is the row, column. Okay, and distance of this particular cell will be 0 because this is the starting node. It will be 0. And initially our answer, we have to what have to do? I have to know the answer. We don't need to actually ultimately, because in priority queue we always know that we'll explore that first, whatever the minimum steps. So we will always first get the minimum distance. Now in priority queue we actually have the starting node 0, 0. By using the 0 number of steps I have reached here because this is a starting. And first of all I will pop that, and if I reach the destination, if we already reach the destination means r comma 1 minus column -1. So this is m minus 1 comma n minus 1. If it is, then return the steps, number of steps by using minimum number of steps I have reached here. And if the number of steps, because this is a duplication possible, how? Why? Suppose in this way, suppose in this path, when I was exploring, I got something a number of step s1. In this path also I got s2. So in priority queue, this is minimum priority queue. So it will be, suppose s1 is less than s2. So s1 will be explored first because I have used the minimum heap, but s2 is have actually entry in the priority queue, correct? So what I have to do? When actually going to this s2 as a element from the priority queue, I have to check that is this distance valid or not. How actually valid? If I will show that have I already explored s1, whatever distance, the minimum distance I can reach this particular node, it is less than the current distance, then this is a duplicacy, or means not a valid steps, not a valid moves, not a valid path. So I'll continue, go to the next node. So if it is a valid path, what I have to do? I have to know that this cell actually teleportation is possible or not. So first of all, find out this character. So if character is between A to Z and not used, I have not used this character teleportation before. So first of all, mark this as true, because second time I can't use this character. And I have to explore all the position. This same character is present. So how actually you can get this? I will get from the map, and I will traverse all the position. And what to do? I will check that if the current steps is less than the distance of the particular cell I can actually reach. So if it is possible that somehow we have reached here, here also A, here also A. So by using the number of S1, S2, so I have already explored stored this particular A. I can reach S2 number of steps, and currently I am in this cell particularly. Here also it is A. Now what actually I can do? I will check that I can also reach S1, this cell also A. So I'll check that this S1 is less than S2 or not. If S2 is already less than S1, that means I have a better path. Don't go to this path, correct? So that's why I will not add this. If it is less than the path actually I have currently, then actually I will only store the steps, number of steps I required, and also store this into the priority queue, because it may be possible that path and that path actually may give us the better result. So that's why I'll store this into the priority queue. Else I will not store this into the priority queue also. Now this is for teleportation case. Teleportation. Now another normal case is that I can, for empty and letter both are possible, I can go to the neighbors. 4 neighbors are possible, so I have to explore all those. So that's why I will first find out that what is the new row and new column. Okay, so if it is valid cell, how it will valid that? Valid will be like if it is greater than equals to 0 and less than row. Similarly for column also greater than equals to 0 and less than column. And when actually I can move to the next cell if it is not an obstacle. So how will I do that? I will find out by checking that 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 new row, new column is not equal to has character has means that cell actually have obstacles, so I can't move to that cell. So if it is not a has, that means this is, either this is a empty or this cell actually have some letter between A to Z, correct? Then actually I can only move. So I'll check that if that cell actually not yet explored, or if it already explored, how many actual steps it is required to reach that. So if it is less than that, so how many actually steps required to reach that particular cell? Steps plus one, because I need actually one move here, and the distance is, it is stored in this particular new row and new column. If it is better result I am getting, so then actually I will store this into the then only I can actually modify that and store this into the priority queue. So that's why I am storing this this particular this steps plus one, and go to the actually the store this in the priority queue also. Then the steps plus one and the new row and new column. Got it? In this actually I will explore all the valid or the next better cell to reach to the destination, because here actually using the minimum heap. Got it? How actually why actually I'm not using the DFS, why actually I'm using BFS, both are got how actually getting the point, right? How actually getting the optimized version. Now what I have to do, I have to check that if ultimately if if I have not reached and not able to reach the destination, so that means this condition is never said true, never true. So that time ultimately, and I have explored all the possible valid moves. So ultimately we have to return -1. Got it? So I have shared this code in the description. You will check that. Thank you.